Module 10.1, Timbre. Have you ever thought about the fact that you can identify someone's voice without seeing them? If you are a musician, have you noticed that if two people are playing or singing the same music, that you can tell they are different instruments or voices? If you hear two people saying the same thing, do you notice that they sound different? That's because of a difference in timbre. Timbre is another word for tone quality. Timbre is the quality of a sound that allows us to differentiate between two sounds that have the same pitch, loudness, and duration. Differences in timbre are mostly the result of differences in the amounts of different frequencies that make up a sound. You may remember that when you did Lab 8, you looked at the different frequencies that made up the note C in 4 different musical instruments. These graphs, which show the amplitudes of the different frequencies that make up a sound, are called spectrums. The trumpet, guitar, and marimba played the note C4. Even though they are playing the same pitch, it is obvious that they are different instruments. Look at the different spectrums. The trumpet and guitar have all of the same harmonics, but the amplitudes are different. For example, F1 is the strongest partial for the guitar, where F4 is the strongest for the trumpet. The guitar has stronger high frequencies than the trumpet. The marimba has only 3 strong harmonics, and even though the slide whistle's pitch is an octave higher than the other instruments, you can see that it has mostly odd harmonics. So the differences in number or amplitudes of frequencies are the main part of what makes timbres different. Timbre descriptions. It's important to be able to describe timbre in terms that we use in everyday conversation. Many of the descriptive words we use to describe sounds are borrowed from visual experiences. For example, bright and brilliant refer to sounds that have a lot of high frequencies, whereas dark refers to sounds that have a lot of low frequencies. Here's a short list of some common words used to describe the timbre of sounds. Helmholtz timbre categories. Hermann von Helmholtz, of Helmholtz resonator fame, was a German physicist who did many studies analyzing sounds and came up with 4 main categories of timbre. 1. Pure tones, sounds with few harmonics that can be characterized as soft, pleasant, and smooth. At low frequencies, they would sound dull. A tuning fork or a wide-stopped organ pipe would be an example. The next category is sounds with a moderate number of harmonics up to the 6th. Sounds in this category sound rich and sweet. If there are not many upper harmonics, the sound would be heard as being soft. A flute, piano, human voice, and French horn would be examples. Sounds with only odd harmonics are the 3rd category. They sound hollow. If there are more harmonics, the sound is nasal. If there is a strong fundamental, it would be rich sounding. If the fundamental is weak, it would have a poor sound quality. A clarinet, narrow-stopped organ pipe, or a slide whistle would be an example. The 4th category is called complex. This would include sounds with strong harmonics above the 6th harmonic. Complex sounds are characterized as being distinct, rough, or cutting. Examples would be a saxophone or an electric guitar. Here's an interesting example. When an electric guitar player adds distortion to the guitar sound, many upper harmonics are added to the sound. Here are the spectrums of a guitar with and without distortion. Notice all the extra high harmonics on the electric guitar. Listen to the differences in sound. To review, Timbre is the quality of a sound that allows us to differentiate between two sounds that have the same pitch, loudness, and duration. Differences in the amplitudes or number of frequencies that make up a sound are what make timbres different. A spectrum is a graph that shows the amplitudes of the frequencies that make up a sound. Helmholtz came up with a way to describe the timbre of sounds based on frequency content.